In the previous video, we had discussed the relationship between K and Kb. In this one, we are going to be talking about problem 7.23 in your new textbooks and old textbooks and 6.23 in the new ones. So basically the concepts that you need to know, you have to have a basic idea of the previous sets of concepts that have been discussed. So definitely check out the videos related to ionization of weak bases, pH, and also the relationships between K and Kb, because it is quite important for you to know those concepts before you solve this problem. Okay, so determine the degree of ionization and pH of a 0.05 m of ammonia solution. The ionization constant of ammonia can be found on table 7.7. Also, we need to calculate the ionization constant of the conjugate acid of ammonia. So it feels like the question is asking a lot of us, right? That is because it is. So first of all, let's write down what's been given to us. Okay, so the things that have been given is concentration, which is equal to 0.05 molar. Okay, we've also been given Kb, the value of Kb, which is equal to, and it is in your textbook, so definitely check that out. It's under the concept of relationship between Ka and Kb. So it's 1.77 into 10 to the power minus 5. Okay, so these two have been given to us. What we need to calculate is, first of all, we need to figure out what is the pH. Okay, we also need to find out alpha, which is the degree of ionization, and we need to find the value of Ka, which is the ionization of the conjugate acid. Okay, so if that's the reason I was like, you need to have a basic idea of all the concepts we've discussed in the past couple of videos, and definitely check them out. So first of all, what we're going to do is we're going to write the reaction or the equilibrium reaction. So NH3 plus H2O is in equilibrium with NH4 plus OH minus. Okay, so for this particular reaction, the value of Kb, the value of Kb will be equal to concentration of NH4 plus into concentration of OH minus, because this is giving us these two, so you'll be considering Kb. So you have concentration of NH3, right? So this is the value of Kb. Okay, now first of all, the concentration of OH itself would be equal to C alpha. Okay, and this is again from what? It is from our discussion related to ionization of weak bases. Okay, in that particular thing, what we considered was that we considered the concentration of OH minus to be equal to C alpha. So the amount of OH that should have come out, concentration of OH should be equal to concentration of NH4 plus, right? So you would have equal amounts of NH4 plus and OH minus. Okay, and again, definitely check that out because I feel like that gives you a more detailed explanation. So we have C alpha because these two have the same concentration. And then the concentration of NH3 itself is going to be C into 1 minus alpha, because when you have equilibrium, due to the we are going to be considering the degree of ionization, right? So we are considering the concentration of ammonia at equilibrium to be 1 minus the degree of dissociation into the initial concentration. So you're going to have C alpha into C alpha divided by C into 1 minus alpha, which is again the same equation that we got then. So it's going to be C square alpha square divided by C into, oh, I guess I could have just done that. So you have C into alpha squared divided by 1 minus alpha. Okay, so this is the equation for Kb. Now, what you have to do, what you need to remember is the degree of ionization is going to be significantly smaller than that of the value of 1. Okay, so we are going to obviously be ignoring the alpha in the denominator. So basically you'll be getting 0.05 alpha square divided by 1 minus alpha, and we are going to ignore this denominator because the value of alpha is significantly less in comparison to the value of the 1. Okay, so you will be left with kb is equal to 0.05 alpha square. Okay, and we know the value of kb is 1.77 into 10 to the power minus 5. So you'll have 1.77 into 10 to the power minus 5 is equal to 0.05 alpha square. Okay, so alpha square will be equal to 1.77 into 10 to the power minus 5 divided by 0.05. Okay, now the next step we're going to do is divide these two, right? So you'll be getting 35.4 into 10 to the power minus 5. Now we know the next step is going to be taking the square root. To make our lives easy, what I'm going to do is I'm going to change this minus 5 to minus 4. So for me to do that, what I will do is I will switch this decimal point to the left side. So you'll have 3.54 into 10 to the power minus 4. Okay, so alpha square is equal to this. So alpha would be equal to root over 3.54 into 10 to the power minus 4. Okay, now when we take the square root of 3.54, we get the value of 1.881, and then square root of 10 to the power minus 4 will be equal to 10 to the power minus 2. Right? So this is the value of alpha. Okay, now so this is the value of alpha, which is the degree of ionization. Degree of ionization is 1.881 into 10 to the power minus 2. It's pretty obvious that it's significantly less than the value of 1. Oh, sorry. Oh no. Okay, I swear my laptop's glitching a little bit. All right. So the next thing we need to do is figure out the value of concentration of pH, right? So that we can do it one of two ways. So the first way is going to be just using the concentration of OH minus, and this is equal to C into alpha, right? So that is going to be C is 0.05 into alpha, which was calculated to be 1.881 into 10 to the power minus 2. Okay, so this will be equal to 0.090405 into 10 to the power minus 2, or we are going to get 9.40 into 10 to the power minus 4 molar. Okay, now we can calculate the value of pH one of two ways. Okay, we can either calculate the pOH, and then we can do the calculation of pH plus pOH is equal to 14. Okay, so that is one way of doing it. And the other way is, I'm pretty sure this is what is given in your textbook, where they use the value of KW. Either way, you get to the same answer. I just found that doing it this way made more sense in my head. So pOH will be equal to negative logarithm of 9.40 into 10 to the power minus 4. Right, so this is equal to minus log 9.4 in plus log 10 to the power minus 4. Right, so this would be equal to and log of 9.4 is 0.973 minus 4, and this is again equal to 3.027. So this is the value of pOH, and we know pH plus pOH equals to 14, right? So what I'm going to do is pH will be equal to 14 minus pOH, which is 3.027, and that will be equal to We're just subtracting it. So you get 10.973. So when you do it this way, it feels more easy because we are going to be following the same set of steps. And I don't know, I just find avoiding division. It's again a personal preference. If you want, you can use the formula Kw equals to concentration of OH minus into concentration of H plus. And then you will be using value of Kw just 10 to the power minus 14. And then the value of concentration of OH minus, you can calculate the concentration of the hydrogen ions. And then you can take the negative logarithm to calculate the pH. So you can do it either way. I just found that this was easier, and I'm pretty sure if I remember it correctly, I'm pretty sure in your textbooks they go through it with KW, but you can do it this way too. And if you want me to explain that, definitely I can drop a comment in the comment section if you wish to. So that's how we calculated the value of pH. The last thing we need to do is calculate the value of Ka. Now Ka, we know we got a very important relationship in between K and Kb as Ka into Kb is equal to Kw. Okay, so this is very important, and this is for only a conjugate acid base pair. So we have the value of Kb, we have the value of Kw, we will be able to calculate the value of Ka. So it's going to be like a simple substitution. So Ka into 1.77 into 10 to the power minus 5 is equal to Kw, which is equal to 10 to the power minus 14, if my memory serves. Yes. So that is 10 to the power minus 14. So Ka will be equal to 10 to the power minus 14 divided by 1.77 into 10 to the power minus 5. Okay, so this on further simplification will give us 0.564 into, when you take this 10 to the power minus 5 from the denominator to the numerator, it will be 10 to the power plus 5, right? So 14 minus 14 plus 5 will give us minus 9. So 10 to the power minus 9. And if you want to, you can switch to this and then just say 5.64 into 10 to the power minus 10. So essentially what we did was we used the basic ionization, like the relationship for ionization of weak bases to calculate the concentration of, or first of all we calculated the degree of ionization, and then from there we were able to calculate the concentration of OH minus ions, and then we were able to calculate the POH, and then pH plus POH equals to 14. Again, you can do it, oh sorry, you can do it this way as well if you wish to, and then you would be able to calculate the pH, right? So after that, we were able to use the important relationship, that is Ka into Kb for a conjugate acid base pair is equal to Kw, and we were able to calculate the value of Ka. So with that, we're done with this video. In the next video, we are going to be talking about di and polybasic acids and di and polyacetic bases.